This is day 8 of Unit 7, so the last day of the notes that you will have. So this is very short and you don't have an assignment for today, so my hope is that you will start on the quiz, so you'll have like 2 days to work on it. So just get through this video, take the notes, and then go ahead and start working on your quiz for the week. Okay, so we're looking at polar equations for conic sections. So there's a way to take a polar equation and look at it and tell what type of conic section it's going to be without having to actually change them over to rectangular form. So it's really nice. So they have to be in either one of these forms. So C is going to be just some constant on top. It's going to say 1 plus or minus, so that means it could be plus or minus. Okay, this could be either one. It's going to have a value here, a constant, which we're going to refer to as E, which is eccentricity. And then it can either have cosine or sine. So these are the two same equations, just one has cosine, one has sine. Couple of things here. So we are going to be focusing on this E value. But in order for that to be E, that means that this number right here has to be a 1. If this number is not a 1 here, we're going to have to factor out and make it a 1. So we're going to need this E. E is called eccentricity, which we did talk about when we were doing conic sections. Depending on what E is, then you can tell what conic section it's going to be. So, if your E is less than 1, it's going to be an ellipse. If your E, or your eccentricity, is greater than 1, it's going to be a hyperbola. And if your E is equal to 1, then it's going to be a parabola. So just looking at this equation, whatever your E value is, whichever category it falls in, tells you what conic section it's going to be. So, let's take a look. So for the first one, we have R equals 8 over 1 minus 0.5 sine theta. So you just need to check out your polar equation. It should be a constant on top. It should be a 1 here, which it is. So I'm going to put a little check so we know we got that. So this can be a plus or a minus here. So the number that we're really focusing on is 0.5. So our eccentricity is 0.5. So because that eccentricity is less than 1, this is going to be an ellipse. And that's it. That's all you have to do. So for the next one, we have R equals 6 over 1 minus cosine theta. So it should be a constant on top, which it is. Should be a 1 out front, which it is. It's negative, which is fine. There's no number in front of cosine, so it's really a 1 there. So that 1 is what we're looking at. So our eccentricity is 1. It says if eccentricity is 1, then we are working with a parabola. Okay, and then the next one. So it should be a constant on top, which it is. It should be a 1 front, which it is. Minus is fine. We're just taking a look at this 5. So our eccentricity is 5. Because that eccentricity is bigger than 1, then this is a hyperbola. So as long as you have this in the correct polar form with this 1 here, you're just taking a look at this number, and it just tells you the eccentricity, and from there you can tell what type of conic section it's going to be. So, let's see what happens if that number is not 1. So if we take a look at this first example, okay, so constant on top, we have that, but this is not a 1 here. So what you're going to do, if that's not a 1, perfectly fine. You can make it a 1. We're going to factor out whatever that number is that's the problem. So this is the same thing as 15 over. We're going to take out the 4. If I do 4 divided by 4, I'll have 1 here. So technically you're dividing both these things by 4. And if I divide that by 4, I'll have another 1 there. Okay? So this 15 over 4 you can technically move to the top. So you can just ignore this 4 now. Now we have our 1 there. And now the number that we need to use for our eccentricity is 1, which means this has to be a parabola. Okay? So if there's a number instead of a 1 in the denominator out front, you just factor it out. So for the next one, so we have constant on top, so that's good. But we have a 3 here. So, no problem. We're going to factor out that 3. So, in other words, divide both things by 3. So, that'll leave us with a 1, which is what we want, minus 5/3 sine theta. So, now we have our 1 here. We have 5/3 with sine, so our eccentricity is going to be 5/3. So E is bigger than 1, so we have a hyperbola. Okay, and then the next one. Okay, so we have the constant on top, which is good, but problem, we have a 4 here. So we're going to factor out that 4. If we divide both of these by 4, we'll have 1 plus 2/4, or 1/2 cosine theta. So now we have that 1. So 1/2 is our eccentricity. Because E is less than 1, that means this has to be an ellipse. Okay, so if the number in the denominator is not a 1, it's not a problem. You just factor it out to fix it. So there's 3 examples left. We'll just work through these. Normally this is like your assignment, but just going to make this all one thing. So we just need to tell what the eccentricity is, and we need to tell what type of conic section is going to be based off of that. Okay, so for the first one, constant on top, so we're good. It already has the 1 here, so you don't have to do any factoring. So 3 is our eccentricity. Because the eccentricity is bigger than 1, then this is a hyperbola. Okay. And then with the second one, constant on top, so we're good there. But this 2 is a problem, so we're going to factor out that 2. If I divide both of these by 2, we'll have 1 plus 1 cosine theta. Okay, good. Now this is a 1, but now we have a 1, so our eccentricity is 1. Whenever the eccentricity is 1, we have a parabola. Okay, and then last problem. Okay, constant on top, but we have this 4 here. So we need to factor out that 4. If I divide both of these by 4, I'll have 1 plus 3/4 sine theta. Well, now it's a 1. So the eccentricity is 3/4. Because the eccentricity is less than 1, this means that we have an ellipse here. Okay, so guys, what we did here is we had polar equations. We'd never changed them. We didn't change them back to rectangular. We could have, but this is a way to tell just by looking at what the eccentricity is, what your type of conic section is going to be without having to put it in the rectangular form. So post these notes and then go ahead and get started on your quiz that's due tomorrow.